So what we are talking about today is about Amazon DynamoDB. So by any chance, have you used Amazon DynamoDB in past?
No, I haven't. I have used Azure Cosmos DB, but that was for a POC purpose.
Okay. Is it much similar to DynamoDB or something different?
I think that is also NoSQL, but in terms of similarity or like
Okay, okay, okay.
pros and cons and all, I'll have to dig deeper.
Okay. Sounds similar. So what we are doing today is we will discuss around Amazon DynamoDB, just the basics of it. I mean, not much into the depth. You can take this as a very beginner friendly session kind of thing. Okay. And I captured this note from chapter 10. So there are like different databases which are discussed in chapter 10 of systems and on AWS storage services. So I took summary of notes from there. So what Amazon DynamoDB is, the basic description before we get started. So the key thing is it's a fully managed service, so you don't have to manage the servers basically. Much similar to what you do in case of any of the services such as relational database service RDS, which is like where you have to specify instance type and then you have to do that kind of thing, right? So here you don't have to manage server, so you are like completely, I mean, you don't have that operational burden at your hand. Other thing is it's a key value database, so it's a non-relational so it is not a relational database, so you can term it as a non-relational database. It is a key value database, so basically you have a key and then you define a value against it, much similar to document databases as well. Like if you can specify a key for your document, then you can store those into this Amazon Dynamo. So you can treat this as a key value database or document database per se. The very good thing which is advertised for Amazon DynamoDB is it offers consistent single digit millisecond latency at any scale. So if your queries are pinpointed, like not you are not running scan and all those things. So if your queries are pretty straightforward, or like you are pointing to directly the data uh, through keys, the primary keys, then it offers a single digit millisecond latency. And this works at any scale. It's not that like if your scale increases, then the latency will increase or something like that. It doesn't happen. It offers that consistency. Now, how you define the data in Amazon DynamoDB? So, like for like how we understand non-relational databases, that there is no schema or there is schema-less database kind of thing, right? Uh, so the idea is for non-relational database, you have to define minimum parameters. Okay, you don't have to define all the rows or like relations or all those things. What you have to do is you have to just define one or two parameters. Now those one or two parameters in case of DynamoDB are partition key and sort key. How you define or like how you uniquely identify a item in case of Amazon DynamoDB. So partition key helps you to identify how your data will be stored. So think of Amazon DynamoDB as a bunch of storage nodes. Okay, so it works on based on leader follower architecture. So you have leader storage nodes, you have follower storage nodes. So think of your architecture as like combination of these storage nodes. Now DynamoDB has to figure out where this data has to be resided. Okay, where this data will be stored. Now that is done with the help of partition key. This partition key should be specified when you are creating a table. So whenever you are creating a table, you are given an option that this is your partition key, this is your sort key. Sort key is optional. Partition key you always have to specify whenever you are creating a DynamoDB table. So once you specify this partition key, and then when you store any items, okay, you specify this partition key. Now depending on this partition key, there is a request router component in DynamoDB which figures out that okay, this is my partition key. I will walk it through my internal hash function, and then depending on what value I get, I will store the data to the physical partition. Okay, so this will be helpful at the time of querying as well. Okay, this request router can figure out which particular storage node this data is present, so it can go there and then fetch that data. Okay, so this is how like what partition keys. There is another key which is sort key. Okay, so whenever you are, as I said, right, it's an optional attribute. So let's say if you don't specify sort key at time of table creation, then your partition key becomes a primary key basically. Okay, primary key, when I say, it means that it is an identifier which uniquely identifies that particular item. Okay, if you specify the sort key, then your primary key is combination of partition key and sort key. Okay, so the combination of partition key plus sort key should be unique. Okay, so that's the idea. And if you specify the sort key, all the items in the same partition are sorted by that sort key. So this can basically help in whenever you are making trying to do some queries. Okay, so let's say you have used timestamp as your sort key. Now you, at the time of querying, what you can do is you can specify a time range, that okay, I need data less than this time or between this time and all those things. So you can do all those sort of operator level operations if you have defined the sort key. So it's always recommended, though it's not required, but it's always recommended that you specify both partition key and sort key depending on whatever access patterns you have. Now, the next thing is, I said that DynamoDB is fully managed service. So how it is built basically, okay? What kind of uh, things as customers we need to specify. So it operates on different kind of capacity modes, we call them. So the first thing is provisioned, okay? In here, what you do is you specify RCU and WCU. Now, DynamoDB definitely needs some metric on which they will charge. Okay, so they charge based on how much data you store, okay, and how much data you retrieve. Store plus, I mean, how much data you read and how much data you write. Okay, and then there is a separate storage cost which is applicable once you breach, once you reach a certain limit. Okay, but the main parameters for your billing will be RCUs and WCU. RCU is read I forgot the definition. I think read consumed unit, and WCU is write consumed units. Okay. Now, one RCU means 4 KB of data. Okay. So let's say you made an API call. Now you are retrieving some data. Now, if this data is, let's say, 5 KB, then that will be treated as 2 RCUs. Okay. 4 KB plus 1 KB, and for one WCU is equal to 1 KB. So if you're, let's say, writing 3 KB of data, in that case you will be consuming 3 WCUs. Okay, so this is one thing that in case of provisioned mode, you specify that okay, I need this number of RCU, I need this number of WCU, and you will be billed according to that. You can treat this as much similar to that you specify the number of instances, okay, the machines you need to serve your workloads. Okay, now the next thing is you can configure auto scaling on top of it. You have defined the base numbers, but what you can do is you can also define lower bounds and upper bounds for them. That let's say if there are more requests coming, uh, probably I have specified WCU as 10, but I need more workloads to be served, right? I like at certain time probably I need 15 WCU. So what you can do is you can configure auto scaling. Okay, depending on some metrics, if that is breached, your WCU will be increased and your requests will be handled. The next thing is fully serverless mode. Okay, DynamoDB calls it on demand. In this case, what it do is, like, you don't have to specify WCU, RCU or anything. The idea here is DynamoDB will automatically scale up and down depending on whatever workloads or like whatever number of requests which are coming in. So that's the idea of on demand, much similar to, let's say, your like managed containerized services. Let's say in case of AWS ECS Fargate or EKS Fargate, okay, or Lambda per se, like function as a service services. So that's the idea of on demand. It's fully serverless. You don't have to specify anything. You just store data, and then it's the responsibility of DynamoDB to manage RCU and WCU. Okay, there is one small caveat in this, which is it is so like it specifies some base numbers. Okay, so for RCU I think it is 3000, and for WCU it is 1000. And if you're, let's say, breaching that limit, now in that case, for a certain point of time, let's say 1 minute or so, DynamoDB will scale the traffic and then increase that threshold to double of whatever it was earlier. Okay, so that's the one caveat, that throttling or throttling scenarios can still occur with case of on demand, provisioned with auto scaling, and provision definitely. So with all these capacity modes, throttling and still happen. Throttling basically means you have specified certain limits and you are breaching those limits. That's what throttling, when throttling happens, and it throws a throttling exception. Cool. Now, next thing is how you access the data or how you write the data. So you treat this as much similar to any of your REST service. Okay, it is not as your traditional database per se, that you have direct access to the database, right? Uh, you have access to the APIs. So there are separate APIs which are exposed: put API, get API, query, and then scan. Okay. Uh, how they work is like, put is helpful to write data, get is used when you know the primary key attributes. So if it's partition key, only partition key, then you specify partition key in get. If both partition key and sort key are defined, then you specify both. Then you can do get query, get request. Query is helpful if let's say you just specify partition key, okay, and there is also sort key, but you want to get all data within that partition. Okay, so you are not defining all the primary attributes, you are just defining part of it. Okay, so that's when you run query. The one use case which I was mentioning, that you specify partition key, okay, and then you specify sort key as let's say this is between time less than 11 p.m. So you will get the data which is less than this 11 p.m. Or let's say if you specify some epoch value, so you can define that time range and all. So this is where your query is helpful. Scan is like you don't specify anything, you just basically run through the entire table and then do some sort of filtering. So it is generally not recommended unless you have a specific, very pinpointed use case that you will have to scan the data. Otherwise, it's not a recommended option because it scans the entire table and then you are billed for that RCU which you are consuming for scanning that entire table. Okay, and there are separate APIs for transactional. So DynamoDB also offers transactional support. Transactions, when I say ACID properties, atomicity, consistency, isolation, and durability. So DynamoDB also offers transactional support. There are APIs for both, I mean, retrieving the data and then storing the data. So transact read items and transact write items, which can be used to store the data. Now, the idea here is that basically, let's say you want to write two entities. Okay, so in that scenario, uh, you can specify in that transaction that either two of them succeed or both fail. Okay, so that's the idea of transaction. In case of read as well, what you can do is either you retrieve both of them or you just you retrieve nothing. So 0 or 1 operation. Okay, so this is the idea of APIs. Now the next thing is indexes. So when I say indexes, what I mean from them is I mean much similar to your relational databases only. You use indexes because you want to optimize your queries. They can't be directly served with your requests which are there. So there are two type of indexes which you can create. First one is LSI, another one is GSI. LSI is your local secondary index, GSI is your global secondary index. There is just basic difference between them. With LSI, what it do is it has to be specified whenever you are creating, like it should be created along with table. So if you are creating a table at that point time, that point only, you have to create this LSI as well. Okay, and the partition key is same as your base table. Okay, you can define a separate sort key for it, but the partition key has to be same. This is the main difference between GSI and LSI. So GSI can be created like whenever you need them, and then you create separate partition key and sort key. So it is kind of a child table whenever you are specifying a GSC, and there are separate RCU and WCU, so you are built accordingly. Uh, One thing I think which I forgot to mention is that DynamoDB can also offer strong consistency. on the read requests. Okay, so it has support for both eventual and strong. If you are choosing strong consistency, then your RCU and WCU are doubled basically. Okay, so whenever you are billed for one WCU, one RCU, let's say. Okay, now let's say if you specify strong consistency, then you will be billed of two RCU instead of one RCU. So that's the main difference. But if that's the requirement that you need strong consistency on your data, then you can specify that. With GSI, you can only support eventual consistency because the data is asynchronously returned to the indexes. Okay, so I mean, whenever the data is written to DynamoDB, it is asynchronously copied to GSIs. So that's the reason that it can only offer eventual consistency. And final notes before we close up. You should always use high cardinality partition keys so that your data is unique across the partitions and you don't face problems such as hot partitions or your data is so skewed or like all those scenarios. So the idea is that always try to choose partition keys with high cardinality. You should always identify the access patterns, like that's how you should always create your partition key and sort key. So one question that can come to your mind is, what will be my partition key, what will be my sort key? So the idea is that you figure out what kind of access patterns you have. When I say access patterns, it basically means how will you read data, what kind of queries will you have. If you know them, then accordingly you can define your partition key and sort key, so that you are build minimally, and then you can retrieve data efficiently in the minimum latency possible. And there is one recommendation for DynamoDB is there is a like it is recommended to create a single table for whatever entities you are storing. Okay, so in relational database, what you can do is like how you can analyze or like try to establish similarity with relational databases, that in case of like relational database, it's a database like where you create database and it is much similar to your DDB table. Okay, now here you have tables. Okay, and in case here in your DDB, what you have is you have different entities which you can specify. Okay, so instead of defining multiple tables, in case of relational database, in here you can create multiple entities and those entities can be stored in your same table. So that's the idea of it. Like I can schedule a follow-up session in which we can take couple of examples around. So one discussion which could be there is that there's like what's the differences between these relational database and these Amazon DynamoDB. Like when should I consider to use Amazon DynamoDB? Today we haven't discussed that. And then another session could be like some of the access patterns, or like let's say you have to design certain schema, then how you will you do it. But yeah, for today, this is all that I wanted to discuss today. Yeah, let me know if you have any questions.
Yeah, thanks for the session. Yeah, I think we can have those kind of things. Also, regarding DynamoDB, I heard that underneath they use this Merkle tree.
I think Merkle tree is specified in that 2007 Dynamo paper, and I think it's
Yes.
used for that basically resolving those conflicts, right? So I think that's the idea. I mean, not as a storage technology, but Merkle trees are used for resolving the conflicts. So let's say if you have data inconsistency among two replicas, now you need some way to reconcile that. For that use case, they use Merkle trees. It can help you to efficiently identify where the inefficiency is, or like where is the difference. Basically, you want to just think of it. Let's say you have two big copies, right? Big replicas of data. Now you identify where exactly is the difference. So Merkle trees help you to easily do that. But in case of the Amazon DynamoDB, I'm not sure what specific technology they use. This was true for the 2000 paper they published earlier. So that was entirely different from this DynamoDB.
Okay.
Yeah,
Okay.
yeah.
Got it.
Any other question you have?
Uh, no other question. But one thing, can you have Mandeep have some session on, let's say, some real world use case of DynamoDB or this kind of AWS technology?
Yeah, we can have that. Let's take another session. Like let's have this session next week only. Around like let's take an example of one or two use cases, and then we can try to design schema for them. And if you get
Sure,
a chance, you
sure.
can check out like in part 3 of the book. There are a couple of discussions where we try to come up for the schema for this different use cases, so you can also check out there. But yeah, we will definitely have one or two use cases and then come up with a schema that how you can store the data efficiently.